Okay, hello everybody. My name's Zelko Milanov. I was the senior marker along with Cheryl Ricks, marking the 2020 HSC Advanced Mathematics papers for questions 21, 28 and 29. We'll get into the presentation for question 21. Before I do that, I'd like to thank all the markers who did an outstanding job in marking these questions so accurately. Here we go. So question one, the tea poured into a teacup and its temperature being lowered. So there's the answers to that question. What's the temperature of tea after 4 minutes as it's being poured? 61.6 degrees. This question was answered really well. Very few problems with this. It's nice to see that some students making the effort of showing that substitution of t is equal to 4 in the actual equation and not just finding the numbers t is equal to 61.589. So the next one was about the rates, the rate of cooling. So there's the solution to the rate of cooling. I'm going to basically give you two feedback forms for this. So one of them is going to be for the students that did really well, so the better responses, and some that the way we're going to need to do some improvement with some of the students. So most of the students that did well linked the word rate to a derivative. They were able to use the reference sheet correctly, avoid making mistakes. And we're also able to show the substitution of t is equal to 4 prior to finding the value for the rate. So putting the t is equal to 4 in is a nice step for the students because they're showing all the working out involved. The problem with some students, as I guess you can imagine, was the fact that they were treating that 1.5 base as they would with a base e, which caused problems in their derivatives. So they're not going to get the same idea out of that. This is well, that's what they did. So treated the 1.5 with it, with the base e. The other types they'd be doing, sometimes the students were doing instantaneous rate rather than they weren't doing the instantaneous rate. They were finding an average rate from t is equal to 0 to t is equal to 4, which was a bit of a problem. That first dot point up the top here, I think I better clarify that some students were using an equation with a base e, so they were trying to change the equation so it had a base e so they can use a derivative, which obviously made problems. Some students got it right, but it did make a hell of a lot of extra algebra for them, and it shows a lack of understanding that there's some key features in that reference sheet that helps them out. So that's that first dot point. And the others we've just talked about. So that one there was treating it as a base E. Part C, how long after the tea is poured will it take for the temperature to reach 55 degrees? There's the couple of variations of the solutions that the students most commonly were doing. In better results, students were able to use log rules clearly and correctly in each step. I can't stress that the idea of each step being shown by the students. Quite often the students were making multiple steps or were using multiple steps in one equation or one line, and then made silly mistakes in the process. So if you can encourage your students to just clearly write down each step that they do rather than use multiple steps in the same line. The other thing that I found, my markers found, was a good thing with the better students. They were able to check the reasonableness of their answer. Those students that got a negative time understood that there was a problem in the question, so they went back and checked it, and more often than not they found that there was a problem in some of their algebra. So negative time probably indicates there's a problem earlier on to go back and check it. Keeping all values in exact form as much as possible helps the final solution there, the final answer, in in terms of their values. In ways to improve student improvement, a better understanding of indices. This was a common error. So just multiplying the 170 by the 1.5 without realizing that power has something to do with it as well. This was another error, not as common as the first one, but still something to keep an eye on and have a chat with your students. Some basic algebra issues there, the 25 plus the 70. Some more areas of improvement. Some of the students were incorrectly writing that in the process of their solution. They were just doing one logarithm instead of having the logarithm split up into the log 3/7 over log 1.5. And then the other issue that some of the students were having was treating the log 1.5 as a natural logarithm. So that the log 1.5 turned into an ln in some of the calculations. This was a major one, I guess. Avoid making too many mathematical steps in the one line. It just makes for a messy algebra and inevitably makes mistakes as they go along. So that was question 21. We'll move on to question 28. So this was the normal distribution question. So the idea behind this one, obviously adults working, this is a two-stage probability. Lots of students, variations of how you can work these questions out. There's three versions there that we just applied here. Better results, students were able to draw a diagram, either a normal distribution or a probability tree, just to get some sort of a visual idea of these what's happening in front of them. Use the reference sheet effectively, so they understood that there was assistance in the reference sheet with a normal distribution clearly given to them there, and understand that the question requires a two-stage probability. In the areas where the students need to improve, there was areas where students didn't actually realize that the normal distribution graph was given to them in the reference sheet. So that was something that needs to be addressed. They were making errors in aligning the numbers up along the horizontal line because they didn't realize that the numbers were already given to them on the reference sheet. Here is a common style of question that was preventing full marks. They sort of had an idea of what was happening. So the first one earns between 15 and 30, getting the right probability there. Then realizing, well, I don't want to earn between those numbers, I'm going to have to take the complement of it. And then when they attempt to do the at least one, then they go back to the start. So that was a problem with not realizing that it was a two-stage probability. So they're going around in circles a little bit there. Here is another idea. So the students really need to look at how many marks the question is worth, because quite often the students might write something out that's 2 lines without realizing, well, it's a 3-mark question. We're probably after a little bit more complexity in their answer. So something to keep an eye on, and a little bit more practice with the at least one types of probabilities in the multi-stage events is something that needs to be improved. Question 28B is there for everybody to have a look at. That was generally well completed. In better results, students were able to write out the probability of adults write some sort of definition of what they're doing, what the 3/4 means and what the half means. So identifying those probabilities was an important factor. Drawing probability trees was a good visual for most students that were doing this. Well, not the ones that were attempting it with that diagram was a really good way of doing it. Having a clear understanding of ratios is obviously something that this question revolved around. So the ones where we needed to improve were a better understanding of ratios. That was a common error. The students saw the 3 times the number. So we're running into 2/3 or 1/3 rather than the 1/4. So the 3/4 and a half. And once again, think of reasonableness of the answer. So if students writing something like that, they get the idea of the ratio, but then write something like probability the adult works is 1/4, indicates there's a lot more people that are out of work that are actually in work. So think of the reasonableness of the answer. Some students were understanding that on that normal distribution, it needs to be split in half for the $25 per hour, but they were using the 99.7% on the probability distribution instead of the actual 100%, which is something to keep an eye on. This was just some unfortunate algebra with some of the students. Some students understood the idea was two-stage, but were writing 2 times 0.185 instead of the square aspect of it. And some students were trying to use, well, conditional probability formulas to get the answer out of this. So it just made a little bit of a mess of that question with the conditional probability. Question 29. With the tangent, so we've got no numbers at all here, which threw quite a few students off. There's the solution off to the side there. There's a couple of solutions there. So areas where students performed better, where students were showing all their working out and not skipping any steps. I think that should be a general theme across 21, 28 and 29, and I'm assuming it'd be across all the other questions as well. Skipping steps is just costing marks. Being able to differentiate that correctly, so the y equals c ln x, reading the question carefully and applying the appropriate substitutions was good for those students that were doing it correctly. Being able to use either one of the two methods over to the right to finish off those questions. In areas where the students need to improve, those students that need to improve weren't showing all the working out. And there was a number of students that weren't actually attempting the question at all, which they need to at least put pen to paper so we can have a look at what their thought processes are with this. Revising differentiation of logarithms is something that needs to be improved on, and by that I mean this is what the students were doing. It's a lot that there was the poorer candidates, I guess, were trying to do a product rule on this, which is fine, but they were making algebraic mistakes with this. So when they were finding the derivative of c, they were turning it into 1 instead of 0 as a constant. Some students were not substituting the x is equal to p in, and this was an error that students were making when they were trying to differentiate the c ln x. They obviously understood that needed to be a fraction involved there somewhere, but they were including the ln x in that fraction instead of just the x part to it. Okay, so there's 29A. 29B, finding the tangent, find the value of c of the tangent in part A. There's the solution. So if the gradient is equal to 1, obviously c over p is equal to 1, and off we go from there. And in better responses, so students once again were able to show all working out. They were able, oops, sorry about that. Let's go back to this one. They were able to make the gradient in A equal to 1, as indicated in the question, and obviously then make the connection of C is equal to P, which is important to finish this question off. Correctly show the substitution of the origin for X and Y in A, and obviously understand how to solve logarithmic equations. In students that needed to have some sort of improvement in this particular type of question. Again, as before, attempting the question and clearly writing their value for C is an important concept. So they were able to, they weren't finding a value for C in this particular question, those students that struggled with it. And there was a percentage of students that were just not attempting this at all either. Showing working out is something that needs to continue and continually be pressed with the students. Better understanding of solving simple natural logarithmic equations, because this, they're able to do some concept of it, but then they get to this line. So you've got ln c is equal to 1. And then from there, they make a mess of the last little bit there. So just to finish it off, they might end up with, they know that there's a 1 there, there's a power. So does the power have to be a 0? Then they might write e to the 0 is equal to c is equal to 1, or e to the c is equal to 1. So getting to that second last line and then making mistakes on that last line itself, just to finish the question off. And lastly, some students were substituting y is equal to 1, thinking that the tangent equation was the gradient instead of the actual m part to it. That concludes my section of the marking concepts. I hope you found them enjoyable, and you were able to take some points out from this and share with your students.